we should just go.
All right.
Yeah, we're going to go ahead and kick off again because we do have a very defined time frame by which we need to be done, and we want to see if there's any questions or anything that we can help you with. But thank you so much. Welcome to the session. Welcome to Red Hat Summit. We're back, which is always fun. This session is Thinking About Edge, Think About Security. My name is Rosa Guntrip, and I am part of the marketing team from Red Hat. And I have a special focus. I'm within the OpenShift business unit, which is probably how most people know us, but I focus primarily on the edge side of the house. And with me, I have Eric Hanselman, who is a chief analyst from S&P Global Market Intelligence, formerly known as 451, in case you saw it on the summary for the session. And then I also have Francois, and I'm not going to try to say his last name because I've been practicing and it's not working. And he's Francois D. Duslil. Duslil? Duslil?
That's perfect.
Oh, beautiful. Beautiful. Okay. And so we're here because we're seeing and hearing a lot about edge computing. And we are in the booth and we're getting a lot of questions as to why, what are people doing, what is edge computing? And what we're really seeing is a lot of organizations are looking to harness the power of data by processing it closer to data sources like devices and IoT devices, as well as users. And here what we did is we put a few of the use cases that we're seeing across different types of organizations. If you've had the opportunity to come to our booth, you will see the manufacturing use case being showcased. You will also see the retail use case being showcased. And so we're seeing this across a lot of different organizations and across a lot of different verticals. But when we think about edge and what it's doing, for example, in a retail space, and you're actually interacting with the user and they're trying to check out their food, if that experience doesn't work, if you get charged incorrectly, it really starts to impact the business. So this is one of the really key things about edge. It's very close to the business and how they operate. But how do you secure it? Especially as you're starting to put your workloads outside of the comfort of a data center, which often has very controlled access, has very much an operations and security team that understands how to control access to the servers and the workloads. And so how do you think about physical security? Sometimes some of these devices can be located in locations like, say, a train station. How do you make sure that people aren't going to tamper with the device? The other one is around how do you protect the infrastructure? As you're scaling out the infrastructure and moving your applications further out, what you're really doing on the other side of putting compute closer to devices and users is you're actually increasing your attack surface. And so how do you deal with that? And the third is really around protecting your workload. The workload ultimately is your interface with your user or with your application and how you're harnessing the data and how you can use it for your business. So how do you then not only control physical access infrastructure, but how do you make sure that your workload remains secure, especially in locations with few to no IT support on site? Again, think about an oil rig, think about all of these places, and in space. We actually have a use case where we put OpenShift in space. How do you make sure all of these environments are in a secure space? And so what we did is we consulted with S&P Global and we said, can you help us understand what are the top challenges and concerns when we're thinking about securing the edge? We have our ideas and thoughts, but it would be great to hear it from the market and actually ask end users what they think and the types of things that are top of mind for them. And so Eric here will help us go through some of the findings that we had from that research.
Hey, thanks, Rosa.
Of course.
To Rosa's point, I mean, we've got, of course, we're analysts. We've got a fair idea about what we think are the primary challenges. We want to take a look at some of the market realities of really what was going on in terms of, especially what is as nebulous a concept as edge. One of the biggest challenges, so we were putting together a study to be able to really take a look at a set of folks who are specifically looking at edge security issues. And one of the upfront challenges we really faced was to narrow that field from, or set of respondents to build that panel. Because I think we've all got to feel that we know something about edge, we define it a particular way. There are so many different ways to define it. We were trying to be very specific about those who are looking at deploying compute capacity into remote locations, outside of the data center. And that qualification process itself was relatively complicated to winnow down the panel to a point at which we were really focusing on those folks who were really tangling with the complicated issues of really executing code in environments in which there are a whole set of constraints that we define as edge. Some of the things are not particularly surprising. We had some expectations anecdotally going into this for what really those focus areas were going to look like, but there's some specific highlights that I think are useful to managers. These are things that, as you look at edge security, they're perspectives that I think are useful for the market. They're also things that, as you try to build cases for justifications for spending on edge security, these are market perspectives that are your peers are doing what's actually taking place in the market as a whole. 2/3 of the company studies, so this is one of the early questions we were answering, is really, what are your expectations over the course of the next 2 years for where your investments are going to be placed? And what are those priorities? How are you actually going to manage that spend? What are you focusing on? And investments in edge infrastructure itself, we classified as edge investments, led that. What we're looking at here was respondents were identifying whether or not they expected spending to increase significantly, moderate increases, stay the same, or decrease. And you'd see edge investments in the top got significant amounts of focus in terms of where they were expecting to increase spend in the greatest amount, combined with both some and significant increase. The other ones we were contrasting it with were edge projects, basically looking at projects of overall deployment to edge as opposed to edge infrastructure. New use cases, basically new services or capabilities, we're looking at it, increasing the number of endpoints or the types of endpoints in terms of overall spend. But it's an indication that a lot of folks that within that panel in the market as a whole, we extrapolate to, are looking at building out edge infrastructure to be able to support their edge environments. That's an indication that we're starting at a relatively low level to build out the capability to really make those first steps. The difficulty with edge, we went out and then asked that panel what their challenges were in terms of being able to build out. Data, network, device security, the top bar up there was a clear leader. We were asking them to stack rank each of these particular areas across this area. And security was really the biggest challenge they faced in terms of what they were looking to address in these areas. Followed shortly by travel costs, of course, being able to actually do dispatch, deployment, service. Again, traditionally a significant part of overall edge cost, edge operational cost. The fact that it was beating out lack of skills, especially in something that, for most organizations, that is as new as edge, a lot of times we see skills gaps being a big part of this, but not getting quite as hard. And then a set of those that were down below it in slightly lower levels. The important takeaway from this is that security aspect is a huge challenge, but it's also an opportunity to be able to go focus in terms of what you're actually being able to deploy as part of that edge infrastructure spend that's going on, to be able to build out security capabilities, to manage and address what is that primary challenge. Security is challenging in any technology environment, but in edge, doubly so. And the focus in terms of what that opportunity is that presents itself to be able to actually ensure that focus areas for spend are actually going to have the capabilities from a security perspective to be able to help them to operate and run effectively. We also looked at scaling and how scale was affecting a lot of these deployments. The interesting thing about the data here, this is basically a chart that's looking at total amount of server infrastructure versus endpoints for edge deployments. And we were expecting something that was relatively linear. In fact, what you can see is it rolls off a bit. And in fact, we're starting to see significantly greater numbers of supporting infrastructure around the number of endpoints that actually the individual supporting server infrastructure, whether or not those happen to be gateways, intermediate compute sites, analytics, processing, whatever that intermediate step is from the endpoints that are actually generating data to that next step in where the computational work is being done to be able to manage it. What the important part from a security piece of this is that it is, as you might expect, growing a significant attack surface in that intermediate compute environment to be able to support growing deployments of edge capacity. That's again basically really a backstop point in the data that you see that really reinforces that this is a matter of ensuring that you can manage security at scale as you look to grow the deployment and the capabilities that you're building out at edge. It's something where we think about the primary takeaway to this is that being able to build security is important. Being able to operate it at scale is far more important. Because as you look to be able to grow that environment, you've got to ensure that operationally you can secure it in the same way. We then looked at, from the perspective of the respondents, what were their expectations that were going to increase risks of cybersecurity incident in one form or fashion, and then what are the greatest threats they were facing, and really contrast these both against each other. On the left is the ordered ranking of what was up there. The interesting piece of this is that those top three, cyber attacks from malicious insiders, cyber attacks from outside attackers, and vulnerabilities, are all close to each other and statistically effectively equal. And an indication about the extent to which organizations are concerned about that level of attack. Vulnerabilities, of course, are an operational concern. We think about what actually is involved. The other piece that's tied into vulnerabilities from the operational perspective is at number 5, which are delays in patching. There are also some quotes from, we had assembled a panel of respondents to really do deep dives and help understand exactly where their primary concerns were and where these fit. You take a look at some of those quotes. The challenge that any organization faces in that attack landscape is not only dealing with the attacks themselves, but understanding what the nature of the attacks are that they're going to be able to have to defend against. Of course, cyber attacks are significant. There's something that we normally expect. But the operational pieces are just as important. And I think the quote down at the bottom is probably one of the most important takeaways for this. I think from an operational perspective, I think we all may have experience in terms of the challenges of ensuring that your environments are well patched, that you're addressing vulnerabilities as they're discovered and released, and ensuring that that cycle between discovery and remediation is as short as possible. The difficulty, of course, is the longer that a vulnerability stays exposed, the greater the likelihood that successful attacks are going to be exploited against it. The other piece, and I think one of the interesting aspects of the study, was we're looking at respondents to be able to identify what do they feel were the best ways to be able to address these problems. What are the things that were most valuable in being able to come at these problems, both from a centralized environment, from a supply chain piece, from the data protections that they were putting in place, and the physical devices that were there. And when we look at this across broad IT, we do a lot of study work around security approaches and values that get attributed to different types of activities to protect this. The interesting thing when we looked at the edge is that what we got back was all of the above. That's an indication from our perspective that folks in edge security want to basically throw everything at this. They're really scrambling to figure out what's effective, how can you actually address what are a complex set of issues in edge security, and really trying to sort out how can they leverage both the tools they have, the tools they'd like to have, the capabilities against this, to be able to effectively secure what is a relatively new environment with a set of threats, and potential mitigations that may be complex to put together. And that really, I think, for me, is the takeaway that these are challenges that people are really wrestling with and don't have really solid ideas about how to address yet in what is a relatively new field. And with that, I hand it off to Francoise to talk about some ways to actually address these problems.
Thank you. So, thank you, Eric. So, I think it's a very good introduction for me to present what is the approach that Red Hat is taking to secure the edge. But before speaking about the approach we take, what are these edge security challenges from a Red Hat perspective? Because if you think to edge, you are thinking about deploying remotely a server. So it means basically that the compute left the national data center, the well-guarded, well-protected data center. So usually when you look at edge, then you do not have this security agent nearby the data center. You may or may not have physical door locked. You have maybe no fence, maybe no badge access. So basically, your edge is becoming really an untrusted location in your network. And you will tell me, yeah, of course, but we apply zero trust along the NSIT SP specification. But at least what is clear is that edge will be less trusted location than a national data center. And it has some implication. The first one is that you cannot really guarantee this physical protection all the time. So it means that if people have access to the device, they can use techniques in order to temper the device. So we are playing on the integrity aspect of security. There is also the risk of theft. It's usually very small device, teeny device. It's much more easy to get access to this device than in a national data center. So we do have some of these devices on the Red Hat booth. So if you are interested to steal them, I recommend to go on the booth and try. No, that was just a joke. But the risk is much higher, of course. So, and supply chain attack, because you have this hardware manufacturer of these small boxes, you might have in between distributor and at the end, the end user of these boxes. So what prevents someone to have a supply chain attack? Software will be probably the most probable, but if you have a lot of money or intent, you may go up to hardware type of supply chain attack. So that's an aspect which is also a consequence to consider. Then, of course, edge, it's a remote compute, but it's still connected with some backend that is going to run in a centralized data center. So it means that it's connected to a network. Okay, sometimes you have a disconnected deployment, but if you are connected, there is a risk of traffic interception at the edge. It can be fixed-based, just the backhaul to the centralized data center, but also the radio that might be on the device. That can be used as an entry point for hackers to go there. So the first one was really about integrity. The second one is more about confidentiality and availability, because since it's basically network attached, you can also try to do those type of attacks against these devices. Another aspect is the human error in edge security. I think we mentioned already that in this location, you are not forcing per se IT and network engineer like you have in main data center. So it means that with an unskilled staff there, you want to prevent misconfiguration, because we know that misconfiguration might be opening a door to an hacker to enter. And I think it was the point 4 on your slide, misconfiguration. That was not the top 3, but at least the top 4. And managing at scale, I think you mentioned that as well. There is a challenge as well with that, because if you want to manage all this fleet of devices at scale, you need to have kind of a remote connection to this one. Usually these devices, they have very limited resources. So if you want to manage the security posture of these devices, you will need to sacrifice some CPU cycle and some resources for the security agent that is going to run on the device. So you may not, for example, deploy the full-blown vulnerability scanner or deployed a huge intrusion detection type of software on this edge device. Then, when you have this fleet of device edge, how do you securely and remotely manage them? You have no choice. The truck roll is no option. So you need to be able, in an automated way, to change the configuration if need be. You may need to secure and to update the software as well. So that's an aspect also that I will speak about. And last but not least, the specificity of edge is that you might have, depending on the use case, of course. I have a telco background, and I have sometimes difficulty to understand what is a limited or intermittent network access, because I was brainwashed that we need to have always 5 nines of availability. But of course, if you are on a boat or in a train, you do not have the guarantee to be always connected. So you might encounter some difficulty to update the edge device if you are using like standard mechanism. And you will see later that we decided to use a specific OS in order especially to deal with this kind of challenges. Lack of security visibility when offline. If you have no network connection, you don't know what people are doing with the device. You have no visibility anymore. I've been putting a link below to an ebook that is getting a bit more into the details of that. So I recommend it to take a look. You will get the slides after the session, after the summit, I guess. So I hope I convince you that there is a security important aspect when you deploy edge, so that you must think about security. What I'm showing here is some of the hardware partners that we have that have been certified as hardware certified program from Red Hat for RHEL. What you can already see is that all these devices are different, right? They might have different interfaces, different amount of interfaces. They have not the same form factor. You have some server-grade appliances. You have like very teeny field deployable devices. So it means that you will need to start with your use case and just to see, what will be your threat surface. Then, when you've been analyzing your threat, you're going to focus on identifying the controls you need to put in place to mitigate these threats. Then you need to onboard this device, right? It needs to be shipped to the location, it needs to be booted, it needs to be connected in a secure way. You do not want to take any risk on that when you are doing the D0 installation of the device. And then you have the day 2, managing at scale. You mentioned it's a concern, and indeed, it's especially if you have a big deployment. So if you think about the use case, and Rosa introduced that on the first slides, you have a lot of industry. So you will have different devices and so on. So you need to identify what will be the threat to your specific edge use case. So who is going to get access to this device? Why? What are the assets to be protected? Is it important? Are you storing like a private key in these devices that can be used to rebound on something more critical? Identify the threat that can happen on your devices. And I put this hacker face with a word cloud, and you see different things. Are you disconnected or connected? The threats will be different, of course. Do you have internet, USB interface that are open, or are you disabling them? Do you have like secret firewall already on this device? So you need to think at the threats that are possible. And then the vulnerability. It's not the vulnerability like a CVE. It's more like a weakness that would make the threat becoming a reality. And when you've been analyzing that, you need to identify the countermeasure, so to mitigate. And of course, I would say it's always a trade-off, because of course it's easy to theoretically enable all the security things, but you have constraints. You have resource constraints, so it means that at the end of the day, if you enable too many of these features, you will have an impact on performances. And maybe your use case has an SLA on performances or on latency or even on the price, right? So what I try to do on this slide, and of course it will not be correct, but it's to make a list per category of the different technical control we have today in RHEL, in OpenShift, that you can already leverage in order to secure your edge deployment. Because of course, what we decided to do from a security perspective for edge, it's to select a an RPM OS3 OS we called RHEL for Edge. So it's derived from RHEL, but it's a transactional and rollback based OS. So it's an immutable, like if you know OpenShift, we are using RHEL Core OS, which is like an immutable or control immutable OS. It's a read-only OS. We decided to go the same way with Red Hat Device Edge. We are using this RPM-based approach. You can see here a lot of things like physical security. Let's assume you have a retail and you have a USB port. What can you do in order to counter this USB-based attack? Oh, you can use USB guard. So it will check if the USB that you insert into the port is allowed to access. If not, it will be denied. But then it's only covering one of the things because USB guard is a daemon. So you may want even to disable USB at the level of the BIOS. Or you may want just to put an epoxy. I was discussing with an ex-Rockwell employee, and they put like epoxy on the USB interface just to be sure that it is not going to be used. And of course, we can spend the full day. I will be available, but you have like the similar things like application security, like encrypting the traffic using IPsec, identity and access management, FA poly-CD, intrusion detection, and so on and so forth. So basically, this slide is showing some proven features like secure boot or UEFI secure boot, use of TPM like root of trust. How can you leverage the TPM if you have a TPM on these devices? You can use that, for example, to store the encryption key if you decide to encrypt the disk. So you have a lot of aspects to be taken, and some are still in the upstream community, like a remote attestation. We have the Keylime project, the open source Keylime project. It's still in the upstream. We are even thinking of using the Sixtor Recore project for durable attestation. Recore is a kind of certificate transparency in order to make sure that we will not only maintain a server with a list of attestation, that it can also be published somewhere on the internet as a way to trust or not the device, but it's not yet available. So we kind of covered you identify your technical controls because you've been doing your threat modeling. Now comes the times of the onboarding. And we were lucky that Intel has been offering its secure device onboarding to the Linux Foundation. It has been the basis to work on an industry specification for Edge and IoT device onboarding, which is called FDO. It's part of the FIDO Alliance. If you know FIDO Alliance, they're working on authentication and device attestation. And what it's doing, it's like securing and simplifying the device enrollment. So very quickly, it's kind of easy. At the hardware manufacturing side, the manufacturing guys is going to put an ID in the device. It's a certificate, an FDO client, and he's going to create an ownership voucher. This voucher is going to be populated in what they call the rendezvous server here. That will be the meeting point between the owner of the device and the manufacturer. When the device will be sent to the edge location, the guy is going to boot up, will connect to the rendezvous server, providing his ID, using the ownership voucher to do the check, and if authorized, he will point to the onboarding server that will contain the file and the secret that will be securely downloaded on the device, and the device is going to be automatically configured. So that's basically the process. So, and in fact, the motivation to do that is because the people that are doing like the in-factory settings, they do not want to deal with all the customization for each customer. In this way, you can have a limited set of templates, build the image, and then go further. And the onboarding server will be the one that will be used to populate the secret of the device. Again, I put some further reading if you are interested to know more on the specification there. So you see, if you want to do this secure onboarding, you need a manufacturing server, you need a rendezvous server, you need an onboarding server, you need to have an FDO client. So Ansible automation platform has been and is currently developing some new collection in order to facilitate all the management aspects of the edge deployment. So the one we just spoke about, FDO, so there is already a link, so you will find a GitHub about device onboarding. So the idea would be to use Ansible to configure all the server and all the steps that you have seen to simplify this secure onboarding. There is also the OS build. So maybe you've seen, yesterday I was in a session about how to produce a RHEL container image, which is hardened using image builder. So OS build is the way to automate everything related to image builder, deploying, patching image, creating new image. So it's a complete collection addressing that. An Edge microshift, which is also in development. So we have this Edge product, which is called Red Hat Device Edge, and it's a combination of RHEL for Edge, the RPM OS 3 based OS I've been talking about, and microshift, which is a slimmed down version of OpenShift, where we remove things because, of course, we cannot put OpenShift on these teeny devices. But what Edge microshift is going to do, it's going to manage the D2 of microshift itself, the platform itself, and the application that are running on top of microshift. So you see, we manage the secure device onboarding, the platform itself, the OS, and also the microshift and the application layer. So before we go, I want to say with any security topic, there is no single answer. So for example, if your edge is a single node OpenShift, it will be bigger, it might be managed differently. So I think there is no universal answer when to cope with security. But what you need to live with is that you have an extensive set of security features all across this product, because the foundation is a trusted OS in different shape and form. Either it's an RPM OS 3 or it's just RHEL. But RHEL, OpenShift, and Red Hat Device Edge, they have all these feature set that can provide you the secure foundation for your edge deployment. The addition of Ansible automation platform help you to manage not only the security features, but of course, some aspects that will be configuration management, secure updates, and so on and so forth. And I want to leave with the last one, which is we continue to innovate with new security features. I've been mentioning some of them, like a Keylime, but it's not only the only things we are doing. We have a project called Coco, which is confidential containers, which is more in the trusted execution environment type of area. So it means that it's still kind of the beginning, but you can already see, where we are heading to. And with that, I would like to say that we are available. I'm available. We have colleagues and product managers that are available. You can come and see us at the booth. We have multiple demos that you can see. And yeah, and with that, I will give the mic, or at least the clicker, back to Rosa.
The clicker.
Thank you.
Any questions that anybody might have? Anything that wasn't clear or that you would like to dig into a little bit more? About 10 minutes. If not, I've come with some of my own. I've gone home with some of my own. No, actually, I have questions for you. Uh-oh. So let's start with you, Eric. We keep hearing a lot about Edge, and I know that as an analyst firm, a lot of organizations, your peers come to your organization to say, where do I start? So based on what you've heard in the survey that we did and your experience in talking to a lot of different organizations, what do you recommend, are the top 2 things that people should think about in terms of where they start?
Number 1 is plan for scale. Biggest, most significant takeaway, if you look at both ensuring your long-term success and also looking at that short-term transition, because we take a look at most edge projects, everyone goes through a proof of concept initially to be able to figure out what they're actually going to be able to deliver as value. But those proof of concepts that don't make it to eventual full-scale deployment, more often than not, are running aground on the rocks of scaling issues. And we talked about some of it today. Francois was talking about some of the issues about how you can address that. Yep. But thinking about scale at the outset and expecting that you're going to need to scale up and take that into account, I think is probably the biggest takeaway in my mind.
Okay. Next one's for you, Francois. Is Red Hat doing threat modeling for its edge products?
Yeah, so we do. So we do have a very big product security organization, and basically there has been like a kind of very organizational change in product security because NSIT has been, there is a lot of focus on software security supply chain after SolarWinds and all the things we've been seeing in the press. So the NSIT has been publishing what is called the SSDF, the Secure Software Development Framework, which is kind of describing how you need to get organized to do a proper supply chain security-wise with your software. And we've been aligning our organization to really try to map this one. That's still in progress because that's not easy to change an organization from one day to another. And as part of that, we have an architecture validation team, and their role is to do threat modeling. So they've been doing threat modeling, for example, on Microshift, as an example, on the OS. And what they do, usually they are not sharing that, of course. So what they do, they are addressing any threat that they see, either directly in the product or through the best hardening guideline to take into account that please be aware that this is a threat that you might be interested to cover. So we are doing that.
Awesome.
Well, and I think it's one of those things, if you think about any real effective security planning, you've got to build a decent threat model.
Absolutely.
You've got to be able to get forward. You're talking about SolarWinds and the supply chain side, but I'd even take it back to Supermicro and the hardware sides and all these kinds of things. But I think to your point, the other thing I think was interesting about the study data that we got, which was that we've got an environment in Edge in which there are a whole set of different threats. This is not something where it's as easy to basically sort of look at MITRE ATT&CK and just sort of say, oh, okay, we're going to pick a bunch of these that are applicable to Edge and then go with them. You've actually got to think a little more coherently about what that edge threat model really looks like and how you're going to mitigate it.
Absolutely, and I think related to threat model, it's also depend. I mentioned, please select your use case. I representing Red Hat into the ORAN Alliance for the Radio Access Network, the security working group, and they've been working on a very extensive threat modeling for the cloudified ORAN deployment, and that's available. So it's a good basis, but maybe it will not be completely applicable to your edge use case. But you can find back very good aspects and worries of all these service provider and vendor that are trying to identify what is the threat model. So it's even not a company threat model; it's an industry threat model about radio, for example.
Well, that's an interesting piece in which if we think about. I'm sure most of you, as you're looking at Edge, it's a matter of figuring out what those particular issues are you're going to deal with and how you address them. Because like the study data was showing that people are just trying to throw the kitchen sink at things. If you have unlimited budget, anybody here have unlimited budget?
If you do, I want to talk to you.
But the reality is you're going to have to pare down your approach to be able to address what the threats are that you expect in your environment. And that, to Francois' point, is you've got to be able to focus and define those threats to address them.
Mm-hmm. But that's a very important topic as well, because what we see also in the threat model is that sometimes they go to an area which is not yet implemented by the technology vendor, or which is only going to be implemented.
All right, the doors have opened behind you, so we're ending our session. Again, we're available in the booth. If you haven't come to the Edge booth, you should. We have some really cool demos. The bottle labeler, we've got point of sale, we've got process manufacturing, in-vehicle OS stuff with the automated car. please stop by. There's a lot of people that will be happy to have conversations with you. And if you have any questions, we're here for about the next 5 minutes, although they told us to tell you you needed to leave. But we can go in the hallway. We can go in the hallway. But thank you so much for joining us.